Here's a continuation of chapter 10.3. Now we're going to talk about the conjugate. So the conjugate is a very special little thing, but it's something that's going to come up a lot over the years. There's lots of different uses of the thing called the conjugate. This is just one of them. The conjugate specifically is a binomial that is just like another binomial, except the sign in the middle of the binomial is different. So when we had, so I can get this adjusted okay for you. So in the last video, we had root 11 minus 2 times root 11 minus 2, because we had a square root 11 minus 2 basically. And we came out with 15 minus 4 root 11. But in this video, we're going to work with what's called the conjugate. So different example, new example, totally new. This is new example. We're going to take root 11 minus 2 and multiply it by root 11 plus 2. That plus sign versus that minus sign, where everything else is the same, makes these two things conjugates of one another, right? This is the conjugate of this. Root 11 plus 2 is the conjugate of root 11 minus 2. So what happens when we multiply this? We're going to multiply, I have a new green marker, by the way, courtesy of Mrs. Isaacs. We're going to multiply root 11 times root 11 plus 2. And then we're going to multiply negative 2 by both of these things as well. So root 11 times root 11, that equals 11. Right? Root 11 times root 11 is equal to 11, root 121. Root 11 times plus 2 is equal to positive 2 root 11. Then over here we have to take negative 2, multiply it by root 11, and we get minus 2 root 11. And negative 2 times positive 2 is going to be minus 4. Now notice that these two terms are going to go away. They are like terms, but they are opposites of one another. We have 2 root 11s and minus 2 root 11s. So they go away, and all that's left is 11 minus 4. So that equals 7. Okay. This always happens with the conjugate. When you multiply two binomials that are the same, what you wind up getting is the O and the I term in FOIL, the outers and the inners. When you multiply the outers and the inners together, you get opposites of one another and they drop out. So that's going to be really cool in lots of ways. The way that's cool in chapter 10 is in rationalizing the denominator. So here's a fraction. In order to simplify this, we need to get rid of these radicals. Well, the best way to get rid of these radicals is to multiply by the conjugate. So we're going to multiply this by root 10 minus root 5. We had root 10 plus root 5, so the conjugate is going to be root 10 minus root 5. And because we're rationalizing a denominator like we did in the last chapter, we need to multiply both the top and the bottom by the same thing so that we are multiplying by 1. All right, let's multiply the top first. The top is going to be negative 3 root 10 plus, because it's negative times negative, plus 3 root 5. That's the top. We don't worry about the radicals being on top. They don't simplify. Root 10 and root 5 don't have any common perfect squares to come out, so there's nothing to do there. The bottom, we're going to be multiplying the beginnings, the middles, and the outers, right? But realize the outers and inners are going to go away. Root 10 times root 10 is 10. Root 10 times negative root 5 is going to be minus, we don't really have to do this, but minus root 50. The reason we don't have to do it is because when we multiply positive root 5 times positive root 10, we're going to get plus root 50. So these go away. And then finally, root 5 times negative root 5, we have minus 5. So the end result of this is going to be negative 3 root 10 plus 3 root 5 over 10 minus 5. And we're done. All right. Next video, I'll show you how to solve some equations, and then that'll be it for the chapter.